Hi there, I'm Jessica, and today we will be talking about indeterminate forms and L'Hopital's rule. So let's get started. So last time we saw how we can use the limit laws to determine the limit of a function as x approaches a value. So for example, with the sum rule, we simply derive the limit of each component and add them together. But what if we're given a function where we can't use the limit laws? This brings us to indeterminate forms. These are characterized by functions that result in any of the following after computing the limit or after plugging in the value that x approaches. So let's look at a quick example. We want to find the limit of this function as x approaches 0. When we substitute 0 into the function, we are left with 0 over 0, or the indeterminate form. But in this case, we can immediately simplify x over x to just 1. Thus, the limit is in fact 1. But we know there exist more complex functions than this example. So let's try to solve the limit of 3x minus sine x over x as x approaches 0. So plugging in 0, we're left with the indeterminate form 0 over 0. So what do we know about this function? We know that we cannot apply the quotient rule because both numerator and denominator result in 0. And we also know that the function can't be simplified like in our last example. So what can we do instead? This brings us to L'Hopital's rule, which states that the limit of f of x over g of x as x approaches some value a is the same as the limit of the derivative of f over the derivative of g. This is assuming that the original limit results in an indeterminate form such as 0 over 0. We must also note that we continue to take the derivative of the function for as long as we continue to obtain an indeterminate form with substitution. Once either the numerator or denominator are no longer 0, we are done. Let's look at an example. Let's try to take the limit of this function as x approaches 0. First, we substitute. Now we need to differentiate the top function and the bottom function both separately. And substitute again. We still get an indeterminate form. We'll need to apply L'Hopital once more. We'll substitute x as 0. And it looks like we'll need to differentiate one more time. We are left with 1 over 6. This is the answer to our limit. Now an example for you to try. Do you recognize this limit?
Contestants, find the limit of this equation.
Calling somebody else fat won't make you any skinnier. Calling someone stupid doesn't make you any smarter. And ruining Regina George's life definitely didn't make me any happier. All you can do in life is try to solve the problem in front of you.
The limit is -1.
Oh, crap.
That answer is incorrect. Now we are in a sudden death. If Miss Heron can answer this problem correctly, we have a winner.
Limits. Why couldn't I remember anything about limits? Limits. That was the week Aaron got his haircut. Oh God, he looks so cute. Okay, focus, Katie. What was on the board behind Aaron's head? If the limit never approaches anything, the limit does not exist. The limit does not exist!
Our new state champions, the North Shore Mathletes.
So how did Katie determine her response? Simply substituting 0 into the function results in the indeterminate form 0 over 0. So we'll apply L'Hopital and take the derivative of the top and the bottom and then substitute. But this yields an integer over 0. According to L'Hopital, this means we can stop differentiating. And since we cannot divide by 0, we are left to conclude that the limit does not exist.